All right, it seems to be working. Go, and we're recording. All right, so technology is going to be our friend today. So we walked through these steps on how we're going to solve our linear system of equations. And at the end of the day, we got 3 pieces of information. We defined what our x vector was, we defined our A matrix, and we defined our B vector. And that's what forms our linear system of equations. So in general terms, we write our linear system equations as A times x is equal to B. And we kind of just have to fill in those blanks. So what was x? And what does x contain? Yes, sir?
The x is the unknown.
So the x contains our unknowns.
And it contains 1 column and 3 rows.
Right, and so x is always a column vector. It's got 1 column always and multiple rows depending on how many unknowns we have. So in this first example, we had 3 unknowns, so x has 3 rows. And we said our x vector, we defined it in class, was going to look like this. T, A, B, T, A, C, and T, A, D. That's what we talked about on Friday. Does it matter which order I put these variables in my x vector? No. But what's important about that order?
You know what it is.
Once we picked it, we know what it is, and then we use that to help us define the order of everything else that we set up in our linear system, our matrix form of our linear system. So it doesn't matter what order we pick. I could flip all these around however I decide, but I have to, once I picked an order, I've got to stick with an order and be consistent in everything else. So I've got my x vector. So that was kind of the first thing that we did. Then we wrote our equations in matrix form. We went through a couple of these steps to figure out how to write those equations, pull out the coefficients, and we were eventually able to make our A matrix. So our A matrix has what information in it? How would you define what the A matrix is?
No, coefficient of unknown.
The coefficients in front of the unknown variables, the terms with the unknowns in them. So matrix containing the coefficients for unknown terms. And so when we wrote out our A matrix for this cable problem, it looked like this, 0.66667, negative 0.408, negative 0.514, 0.667, 0.816, 0.686, 0.333, negative 0.408, and 0.514. So this A matrix is a square matrix. It has the same number of rows as it has columns. What do the different rows in this matrix represent? How do we get a row in the A matrix? The equations that we have. So if we look at, if we go kind of up in our PowerPoint to our 3 equations we had for this problem. Come on. What is it doing? You guys can see, and I can't see. Come on, PowerPoint. You're going to behave now? No. There we go. Okay, so when we have our 3 equations that we have here, we have one row for each equation. So the rows, 3 rows for our 3 equations. And where do our columns come from?
It's from the unknown.
The unknowns. So our 3 columns represent our 3 unknowns. And this is where the order becomes important. So I said my first variable, my x vector was TAB. That defines that this first column corresponds with all the TAB terms. So if we look at our equations we have there, if we look at each one of the TAB terms, those coefficients are what I put in column number 1. 0.667, 0.667, 0.333. And then each one of my columns is for my unknowns in that order that I've defined in my x vector. So TAB in the first column, TAC in the second column, TAD in the third column. So once I pick that order, that's how it becomes important. It defines what that A matrix is. Then the last thing we have is our B vector. And this is another column vector. And how would we define what goes into the B vector? What would you say about that? The known things. So everything else that we have that doesn't fall into the A matrix ends up having to go in the B vector that we have. So our B vector is a column vector of the known quantities, or the known terms. And our B vector always has one column and then multiple rows. And so our B vector for this problem is 0, 981, which is our weight of our block, and then 0. So how do we know how many rows are in the B vector? What does that correspond to? The number of equations that we have. So we have 3 rows because we have 3 equations. The first value comes from our first equation, the second value from the second equation, on down the line. So it just so happens with this problem, because we have 3 unknowns and 3 equations, that all kind of matches up, but we don't always have linear systems equations that are nice and neat and tidy like that. All right, so now that we've got our x vector, our A matrix, and our B vector, we have to now do something with this. So what was the whole purpose of writing these equations in matrix form? Why did we do that? Not because I told you to. That's also a reason, but what was the real reason?
We need to calculate the unknown.
We need to calculate the unknowns, and how are we going to calculate the unknowns?
By the
With MATLAB, right? What else are we going to do in this class? We don't use our calculators, even though I had to laugh at how many people had their calculators out during the quiz. You know MATLAB is a really fancy calculator, right? So I think I'm considering, next time I teach this class, to ban the use of calculators. MATLAB only for all calculations in this class. I feel like it's good for you. It's like taking your vitamins. You must trust the calculations that MATLAB does. Okay. We'll see. We'll see how mean I feel like being next spring. All right. So we're going to now figure out how do we solve these linear systems of equations in MATLAB. So we're going to write, we can write a script, we can write a function, whatever we decide. And there's really not that much MATLAB code we actually have to do to be able to solve for these unknowns. It's just a little bit of code we have to write. So what do we want to write? Do we want to write a script or a function? Script, of course. Everybody's favorite, right? So we're going to write a script to solve our linear system of equations for this problem 1, the cable problem. So what do we do at the top of a script? What should we put up there?
clear.
Housekeeping, right? So we're going to stick in our housekeeping tasks. We have our clear to clear out our workspace, our CLC to clear out our command window, and then I'll just usually throw in a close all. We won't have any figures related to this, but just good practice to put it up there. So what should we do here at the top of our script. We're going to need to eventually define a couple things for MATLAB. We're going to need to define what this A matrix is and what this B vector is. We don't need to tell MATLAB what the X vector has in it. We'll solve for that, and then we, based on how we've set it up, we know what those values are going to be. So the only things we really have to do are define the A matrix and the B vector. If we had any variables or anything like that, you know, any of these equations, we plugged in all the numbers here, but if we had any kind of variables like G or X or whatever else we wanted to put into this, we could define these up here at the top of the script too, but for this problem we just need to define our A matrix and our B vector. So unfortunately with linear systems equations we don't have to write a whole lot of code, but we have to be kind of careful about how we write our A matrix and our B vector so that they get into MATLAB and they're saved appropriately, so that it doesn't get messed up whenever we're trying to solve for these unknown quantities. So we define our A matrix. And how do we write out a matrix in MATLAB? I'm going to say A is equal to, what do I have to do to tell MATLAB this is going to be a matrix? Square brackets, and then I'm going to do my first element, 0.667, and then what do I do to tell MATLAB to move over to the second column? A space or a comma, and then negative 0.408 and negative 0.514. So now I'm going to move down to my second row. So what do I do? Semicolon. So what I usually do when I'm writing these A matrices, because they can kind of get big and confusing, is I end up going down to the next line of my MATLAB code. So I kind of make my A matrix, the way I'm typing it in, look exactly like how I've written it on paper or whatever. That way visually I can kind of see and make sure everything lines up. So the way to do that in MATLAB, if you want to skip down to the next line, is that you just put 3 dots or ellipses at the end of your line. Now you can go to the next line, and MATLAB will still think that that's all part of that big A matrix that you have. So it's just kind of a nice way to organize things when you have big matrices. So on our second row, we have 0.667, 0.816, and 0.686. I put a semicolon, I do my 3 dots, and I go to the next line, 0.333, negative 0.408, and 0.514. Now I'm done with my matrix, so I close my square bracket. I'll put a semicolon at the end. That way it doesn't print out to the screen and MATLAB's happy. The 3 dots helps you go to the next line without MATLAB being angry. So you can continue going in the same matrix. Okay. So that's my A matrix. And now I'm going to do my B vector. So define B vector. And my B vector needs to be a column vector like this. So what are my options to type that into MATLAB? I could do the transpose, so I could write it kind of as a row vector, 0 space 981 space 0, or I could put semicolons after each one. It's up to you, whatever's easier. I usually do the row vector just because I tend to like spaces better than the semicolons. So I'll do 0, 981, 0, close my square bracket, do my transpose, and that'll turn it into a column vector like I need it to be. So that's the hard part. That's the things that we have to make sure are exactly how we've written them down on paper. If we forget a term or something like that, we're going to get error messages from MATLAB that our matrix dimensions don't agree or something crazy like that. That's usually the most common errors you get with this type of problem. So now we need to solve for our X vector. So like I said, we don't need to tell MATLAB what's in X. We're going to solve for X, and then we're going to know what those 3 numbers are because of the way we set up our X vector. So how do we solve for our X vector? So we have a couple different options. So remember, our general linear system of equations is A times X is equal to B. When I want to solve for X, what would I do? If I were to solve this algebraically, I would just divide both sides by A, right? I'd say X is equal to B divided by A. But matrix division is not a real mathematical operator. We can't take a B vector and divide it by an A matrix. That's just not something that you can do mathematically. So we have to come up with some other ways to do it. So we can use a matrix inverse. So we can say A inverse, or A to the negative 1, times A, x is equal to B times A to the negative 1. Oops, backwards. My eraser. Where this is what's called a matrix inverse. And a matrix inverse times itself ends up being an identity matrix, so that kind of goes away, and we're left over here on the left-hand side with just the x. So that's our first option, and luckily we don't have to mathematically calculate matrix inverses. MATLAB has an inverse function, so that's really nice. The other option is kind of a special MATLAB trick. So I said, you know, we don't have matrix division, we can't take B divided by A. Well, MATLAB has this special thing called the backslash operator, and it basically performs matrix division, going through all the steps that you would have to do that in a very quick and kind of efficient way. So instead of doing regular old matrix division, we're going to use the backslash operator. So the backslash operator you end up solving for x, and you end up saying A backslash B. So this is not your normal division symbol. This is the backslash symbol on your keyboard. And if you do that, you end up kind of doing matrix division, and you're able to solve for your x vector of unknowns that you have. We're not going to go into like the theory of how this backslash operator works, but it's a lot like substitution. So if you were to have two variables, you would solve for one of them, plug it into the other equation. This is what MATLAB's doing in the background when it's doing the backslash operator. It's kind of doing that substitution. So these are our two options when we go to solve for our x vector. And we're going to solve them both ways, and hopefully we should get the same answer with both the calculations. Yes, sir?
Did MATLAB do like a reduced row echelon form?
So that's kind of what it's doing in the backslash. So it's kind of doing that in the background. All right, so we're going to solve for our x vector first using the matrix inverse, and then we'll do it with the backslash operator. So usually when I do this, I'll say x inverse. That way I know I've got two different variables, and I can compare the two answers that I get out of them. Hopefully, like I said, they're the same. So we're going to take our matrix inverse. So we're going to say INV, that's our matrix inverse, of our A matrix, multiply that by our B vector, and that's how we use the matrix inverse, so super simple. You'll see that now we have typed in the inverse, and MATLAB has so kindly underlined it and told us, given us some information about it. And it says, here in this warning message, it says, inverse can be slower and less accurate than A backslash B. Consider using A backslash B instead of the inverse. So MATLAB is very proud of its backslash operator. That's like one of the cool things about MATLAB, that it's a special feature that you could only find in MATLAB. It's very proud of it. It's very fast computationally. It's much faster than a matrix inverse. You guys won't notice the difference at all. And they like to tell you that you should use the backslash operator. The reason why I teach you the inverse option is because, again, the backslash is only something that MATLAB has. So if you were to do these kind of calculations, you know, on your own calculator, or you know, in some other programming language, you're not going to have access to the backslash operator, so you're going to have to use the matrix inverse. So that's kind of why I teach you that. We can ignore this warning message that says, you know, consider using the backslash. Yes, I know that. We're going to ignore that and just practice doing both methods for all the problems we do in this class. So we've got our x vector solved with the matrix inverse, and so the other option is to solve for x vector using backslash. And I usually name this one x underscore backslash. And just like I wrote up on the board, A, and then the only thing to realize is where your backslash key is on your keyboard. Mine is right above my enter key. So make sure that you use your actual backslash and not your division symbol. Yes, sir?
What would happen if you did B backslash A?
You're not going to get the correct answer because that is kind of the wrong mathematical order to that operation. Yes, sir?
This doesn't require a dot.
It does not require a dot because we actually want to use kind of the matrix form of these things. If we do a dot, I don't even think that you can do a dot backslash. You would be doing the element by element kind of division or whatever. That's the mathematical operation is this. We actually want to use all the values in the matrix. So we no dot here. No dot for the inverse either. So no dots when we do linear systems of equations.
Like, the inverse and backslash, they work both the same?
They don't work the same, but they will give you the same answer. Or we hope they'll give you the same answer. So let's try it out and see. So now we're done. So this is really all we need to do in this code to solve a linear system of equations. Not too much code. Really, it's just focused on getting the A matrix and the B vector in there correctly. You could do some display functions or whatever it is you want to display the results, but we won't worry about that right now. So let's save this. I'm just going to call it in class exercise problem 1. Oh, in class exercise 9, problem 1. And then let's run it and see what happens. So if we run this, I didn't do any display, but I'm just going to quickly display these two x variables in the command window. So x inverse and my x backslash. Thankfully, we got the same answer from both of them. We should always get the same answer from both of them unless we've screwed something up or MATLAB has some sort of issue with it. And so now we've got these three numbers. How do we know which one is which? MATLAB doesn't care. It just gives us three numbers. We set up our x vector, right? So the way we set up our x vector that determines the order of everything else we have here determines also what these three numbers are. So TAB is 519, TAC is 636, and TAD is 168. So that's how we know what the three answers are in whatever order it is. So if you're doing your homework, for example, whatever order you pick isn't necessarily the order that I picked and got the solution. So I always tell you what the x vector, when I give you the answer for the solution on the homework, I tell you what the x vector is and then what the numbers are that correspond to that. So that way you can match them up. You don't have to solve them in the same order that I do. It doesn't matter what the order is, you'll always get the same numerical answers. They'll just maybe be in a different order. All right, any questions about this? Okay, so for the rest of time,